2004, graphene was isolated by Andre and Costa at Manchester using the Scotch tape method. Graphite doesn't really become graphene until it's isolated from its environment. It comes in a rock and it's dirty, so you know it's a rock, but once you've peeled it, you can't really treat it like a rock. It's a low-tech manufacturing process to make something that's really quite high-tech. I mean, we're still making this by peeling apart bits of rock with pieces of sellotape.
So in that respect, it's definitely a man-made thing.
Graphene and these two-dimensional materials are fairly unique in that there's nothing really like them that's found in nature.
Well, serendipity definitely played a big role in the original discovery. For example, when they first made graphene and put it down on a silicon wafer, there was a huge amount of serendipity on what kind of wafer they put it down on. If they had put it on the wrong kind of oxide thickness, they may not have seen the graphene. So there was definitely the serendipity aspect in that.
Material science is being a bit like a detective. You have to find out what makes a material behave the way that it does. So maybe we try to look at what happens when we add a tiny bit of a different element and see how that's going to change the physical properties, so the strength, or how easy it is to break the material. So graphene is special because it has some very unique properties, and those properties are only present because it has a very, very small dimension in just one direction. So people call it a two-dimensional material. That's a difficult thing to understand, but it just means it's very thin, but only in one direction.
If you imagine you're an electron living in graphene, then you are only allowed to move in two directions. And that's why it's a two-dimensional material.
Graphene is absolutely tiny in one dimension, which means it behaves like a single molecule. Well, it is a single molecule, it's sort of surface. But in the other two dimensions, it's relatively big. We can still, for example, put contacts on it. Basically, I'm trying to use graphene electrodes to measure currents through single molecules. It's nice because its atomic thinness means it has really well-defined contacts on the molecular scale, but then you can extend it out and contact it with metals, which you can then contact to electronic devices and actually make measurements through the graphene.
So my grandma thinks that I study materials and then I must be able to knit. I have to tell you, I can't knit also, really. And so what material science means to me is it's engineering materials, the types of substance that we rely on in our everyday life, such as the metal that we use to make a bridge, the concrete, the components that we use to make a computer chip. It covers a huge range of length scales as well as different types of materials.